Section 2.2 is going to refresh on all three different forms of graphing linear functions. First off, what's linear versus nonlinear? So linear is a graph that makes a straight line. Nonlinear is any graph that doesn't make a straight line. So something like a parabola or an absolute value or anything that curves. Okay, so functions are nonlinear if they have any of the following things. If they have exponents attached to their variables, if they have absolute value around the variable, or if they have any variables in the denominators, in the bottom of fractions. If you don't see any of those things, the function will be linear. First form that we're going to refresh on is slope-intercept form. And the reason this is called slope-intercept form is because when we look at this equation, we can pull out the slope, which is right in front of the x. So the slope is 2/3. And we can pull out the y-intercept. So y-intercept is written as a point, always a 0 for the x there, -5. All right, so if we were to graph this, we always want to start with that y-intercept. So we're going to start at 0, -5, which is down 5. Okay, and then we're going up and over based on the slope. So up 2/3, up 2/3, up 2/3. Okay, and then if we wanted to go down 2/3 from that y-intercept, we'd be down here, down 2/3, and then we just want to connect them all with a line. Okay, arrows at the end since it goes on forever. Okay, number 2, same thing. Okay, so the slope is right in front of the x. In this case, it's an invisible 1. Okay, y-intercept is also invisible at the end there. Okay, so an invisible 0. So y-intercept is 0, 0. It goes through the origin. So 0, 0 for the y-intercept, and then it's going down 1/1. Okay, over and over. Okay, if we went on the other side, it would be going up 1/1 in the opposite direction, and just connect them all. This next equation form, point slope, has both a starting point and the slope built into the equation form. If you look at the equation form, y minus y1 equals m times x minus x1. Those minus signs are supposed to be there. So thought of another way, we're taking the opposite of this x value and opposite of this y value to get the starting point. Slope comes from right in front of those parentheses. So if you look at this first example here, slope is 1/2. And then for the starting point, we have the opposite of this number for the x. We'll have -6. And then opposite of this number for the y, +1. Okay, so we're going to take all that information, -6, 1 for the point. -6, 1 is here. And then we're just going up and over based on that slope. Up 1/2, up 1/2, okay, and then we can just keep moving based on that. Use that to draw a line. Okay, same thing for this next one. Slope is 3/7. Opposite for the x is -2. Opposite for the y is -2. Okay, it gives us this information here. So we have -2, -2 is our starting point. And then up 3/7. 2, 3, 1, 2, 3, 4, 5, 6, 7 puts us here. And let's go one more on the other side. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 puts us down there. All right, gives us that line. Now we can always try to switch this into slope-intercept form. So for example, for this first one, we could have distributed this 1/2 and gotten y minus 1 equals 1/2 x plus 3. Okay, and then we could have added the 1 over and then ended up with an equation in slope-intercept form. Y equals 1/2 x plus 4. Okay, which is what we have here. Starts at 4. Okay, goes up 1/2. Right? If we tried to switch this one into slope-intercept form, it would have been a real pain. All right, so you want to know both methods. The last form is standard form. It's also known as general linear form. Before we graph it, just a refresher on what it looks like and what the rules are. So the form is ax plus by equals c. A, b, and c are integers. They have a GCF of 1, and the coefficient on the x needs to be positive. B and c can be negative, but a should be a positive number. Here are two examples of equations in standard form, and just like point slope form, we could switch these into slope intercept and then just use the intercept and the slope to graph them. Okay, the only issue is that takes a little longer than this other method, which is called the intercept method. So in the intercept method, we want to find the two intercepts. We want to find the y-intercept and the x-intercept. Now, the key thing to remember is that in every y-intercept, the x value is 0. Okay, so we could plug in a 0 for the x, and if we plug in a 0 for the x, 3 times 0 is just gone, and we're left with 4y equals 24, which we could solve, and we would get y equals 6. Okay, so the y-intercept is 0, 6. For the x-intercept, every x-intercept is going to have a 0 for the y because it's where it's crossing the x-axis. Okay, and if that's the case, we could plug a 0 in for the y. 4 times 0 is gone, and now we have 3x equals 24. We can solve that, and we get 8, 0 for the x-intercept. So we have those 2 points, and we're just going to use those 2 points to graph the line. So 0, 6 is this point right here, is this point over here, and then connect them. Okay, we don't need the slope. All we need is 2 points, and then we connect them. Same thing for this next one. So if we just cover up that 5y and find the x-intercept, so 2x equals 10, we get 5 for the x-intercept. Okay, cover up the x and solve for y. -2 is the y-intercept because -5 equals 10. Solve it, we get -2. Connect them.